Okay, here we have section 3, geometric sequences. Let's go ahead and get started with it. Alright, so to begin with, a sequence is geometric if the ratios of consecutive terms are the same. And what that means is if you divide any two consecutive terms, you're going to get the same value. Alright, so let's look at our ratios. If I divide 8 by 2, I get 4. Dividing 32 by 8 gives me 4. 128 by 32 is 4, and finally 512 over 128 is also 4. Since my ratio is always 4, then they are geometric, and the common ratio this time, not difference, common ratio is 4. Alright, so look at these three examples and see if you can find a common ratio between the numbers. Alright, let's see how we did. So looking at that first sequence, to go from 2 to 4, we multiply by 2. To go from 4 to 8, we multiply by 2. And 8 to 16, 16 to 32, each time we are multiplying by 2. So yes, this is geometric, and our common ratio is 2. Looking at our second example, to go from 26 to 36, we multiply by 3. To go from 108 to 36, again we multiply by 3. And last time, multiply by 3 one more time to get 324. So yes, this is geometric, your common ratio is 3. For our last one, we multiply by 3, and then it gets kind of tricky. You can multiply by 9 over 4, and then multiply by 16 over 9. So regardless of how you do this, we are not getting the same ratio, so no, this is not geometric. Okay, so here we have our formula for a geometric sequence. There's a little bit less going on. We need to know the first term and the common ratio. Once you know those two items, you have enough to create the formula for a geometric sequence. Let's go ahead and apply it. Okay, so here we have the first term, it's 3. The common ratio is 2. So the first question is, what is the equation? By plugging these into the last formula, we get a sub n is equal to 3 times 2 to the n minus 1 power. Now we're going to go ahead and plug in some values to find our first 5 terms. Plugging in a 1, I get 3 times 2 to the first, which is 6. Plugging in a 2 for n, I get 3 times 2 to the second, which gives me 12. Continuing my pattern, if I double every time, I should get 24. And 3 times 2 to the third is in fact 24. Finally, doubling one more time, 3 times 2 to the fourth is 48. Now right here we want to find specifically the 9th term. We do know it's geometric, and we know that because it says geometric sequence. We can identify our first term as 7. And how do we go from 7 to 21? Multiply by 3. So we have 7 as our first term, 3 as our common ratio, which gives us 7 times 3 to the n minus 1 for our formula. Then if I want to find the 9th term, simply plug in a 9 for my r value. And when I do that, that simplifies to be 7 times 3 to the 8th. Plugging that all into your calculator should give you 45,927 as the 9th term. Okay, here it gets a little tricky. So again, we have terms that are not next to each other, they're not consecutive. So we have to come up with something creative to help us find our common ratio. What we're going to do in this case is I'm going to be dividing the terms. So my ratio is going to be 1458 divided by 54. And then I'm going to find the 7 minus 4 root of that, which means I want to find the third root of 1458 divided by 54. Now if you guys don't know how to do that in your calculator, then it might be easier to just put this in parentheses and raise it to the, again in parentheses, 1/3 root. Or sorry, 1/3 power. So those are the same. The cube root or 1/3 power, either way you're going to help you find your r value. Okay, so once this has been plugged into the calculator, we get that r is equal to 3. Our next step now is to find our first term. Okay, so let me go ahead and get rid of this here. Okay, I know what r is. I want to find my first term. So again, it's going to use this here. We're going to say that since our formula is a sub n is equal to a1 times r to the n minus 1 power, a sub n is 54, and it's going to be 4. So 54 is going to equal a1 times 3 to the 4 minus 1 power, which means 54 is going to equal a root sub 1 times 3 to the third, which is a sub 1 times 27, which means that 54 divided by 27 is going to give me 2 from a sub 1. I know a1, I know r, so my equation is going to be 2 times 3 to the n minus 1 power. Now one quick check we can do is if I plug in a 7 from my n value, do I in fact get 1458? If you don't, you want to go back and check your math to see if your equation is right. If you do, that means that you have gotten the correct equation. Alright, here we have the sum for our geometric formula. I know it's kind of complicated. This we've talked about, that's summation notation. This over here is the actual equation for the sum of a geometric sequence. So what we need to know is what is our first term, what is our common ratio, and how many terms are we adding together. Generally that's pretty easy to get. Let's go ahead and look at an example to try and calculate this. So here I have a bunch of terms, 5 plus 10 plus 24 plus 40 plus 80, all the way to 640. We could simply add them all together and we would get our sum. But if you had a lot of terms, let's say 100 or 1,000, that could get to be very tedious. So instead we're going to identify a1, r, and n and plug it into our formula. So if we count up all the terms, we could very quickly get that n is equal to 8, and now my first term is 5. By dividing two consecutive terms, 10 over 5 or 80 over 40, we get that r is equal to 2. So now I know those three things that I need to know. My next step is to plug them into my formula. So when I plug them in, I get 5 times 1 minus 2 to the 8th over 1 minus 2. Simplifying that gives me 5 times 1 minus 256 over 1 minus 2. And if I go through all the math, I get as my final sum 1,275. Now let's go ahead and test out that formula. Identify a1, r, and n, and see what you get. Alright, now it's important to note here that there is nothing in front of that 2, correct? So we can kind of imagine that there's really a 1 there as a placeholder, and that would be your first term. So when we go through and identify things, a1 is going to be 1, r is going to be 2, and n is going to be 9. So I have 1 times 1 minus 2 to the nth, 2 to the 9th over 1 minus 2. Simplifying all of that and plugging it into the calculator will give you 511 as the sum of the first 9 terms for that sequence. Alright, your turn. So we have the formula, the sum of the formula 4 times 0.3 to the n. I want you guys to go ahead and try and find the sum. Okay, let's see how you did. Now, I kind of set you up with a trick question here because if you look at our exponent, it's to the nth power, not our usual n minus 1. And what that means is we are going to have to actually find the first term. 4 is not the first term. We have to find it by plugging in a 1. And if you do, then you get 4 times 0.3. So this is actually your first term. And again, that's because this is to the nth power, not the n minus 1 power. Your r value is still going to be 0.3. And we have 12 terms, so now that's my n value. So when I simplify all of this, I get 1.714 as the sum of my first 12 numbers. Alright, now unfortunately, there are two types of geometric sequences. We have a finite, which means we can count the amount of terms, and we have an infinite amount, which means it goes on forever. When we're trying to find the sum of an infinite amount of terms, we have a different formula. Alright, so there's one really important thing to check before you find the sum of an infinite geometric sequence. We want to look at the absolute value of our r value. If it is less than 1, then the geometric sequence has a sum, and you can go through with what we're doing. And the formula for that, again, this is your sigma notation. The formula is actually this part over here, a1 over 1 minus r. If instead the absolute value for r is greater than or equal to 1, then the sum does not exist. So let's go ahead and look at a few examples of infinite geometric sequences. Alright, so here's our first example. We have 3, negative 1, positive 1/3, negative 1/9, and so on. So that dot 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 at the very end, that kind of shows you it's going to keep going, implying it is infinite. And we're also saying we're not finding the sum of the first 10, first 12, or the first partial sum. Alright, so our first task then is to identify what r is and see if we can even find the sum. Okay, so negative 1 divided by 3 is negative 1/3. 1/3 divided by negative 1 is also negative 1/3. So your r value is negative 1/3. Since the absolute value of negative 1/3 is less than 1, we do have a sum. Let's go ahead and find that. So again, the formula is a sub 1 over 1 minus r. A sub 1 is your first term, and we can identify that. We have found our r value. So it's simply 3 over 1 minus negative 1/3. That simplifies to be 3 over 1 plus 1/3. And when you add that together, we get 9 over 4. Which means that the sum of the series is 9/4. Okay, let's take a look at this next example. We have 7 over 2. This time we know it's an infinite sequence because of our sign up top, the infinity sign. And if we look at our r value, it is 7 over 2. Which is greater than 1. Since it's greater than 1, we do not have a sum. We cannot continue. So we just say the sum does not exist. Alright, that's going to wrap it up for section 8.3. Go ahead and start your homework.